A priest, yes, a Catholic priest, not a world-famous scientist, not a Nobel laureate. A priest, standing in Belgium in the 1930s, quietly proposed the most explosive idea in the history of cosmology. His name was Georges Lemaître, and his theory would shake the universe itself. But when he first revealed it, even Einstein laughed. So what did this quiet man of faith and physics see that no one else dared to imagine? Tonight, we follow the trail of clues, hidden in galaxies, in equations, in static from an antenna, that turned ridicule into revelation. This is the mystery of the beginning of everything. For centuries, people believed the universe was eternal, infinite, unchanging. It was a comforting, predictable idea. But in the 1920s, a young Georges Lemaître took Einstein's brand new theory of general relativity and followed the math where it led. And what he found was disturbing. The equations didn't allow for a still, static universe. They demanded motion, either expansion or contraction. Lemaitre reasoned that if the universe is expanding today, then long, long ago, it must have started small, unbelievably small. He called it the primeval atom, a single, incredibly dense point from which everything burst forth. It was the first clue in the greatest detective story ever told. When Lemaitre explained this radical idea to Einstein, the great man frowned and famously said, "Your calculations are correct, but your physics is atrocious." The world wasn't ready. The case was far from solved. But then, just 2 years later, across the Atlantic, another piece of evidence emerged. At Mount Wilson Observatory in California, the astronomer Edwin Hubble was using the world's largest telescope. He wasn't hunting for the origin of the universe. He was just studying distant galaxies. But as he measured their light, he saw something astonishing. The galaxies weren't still. They were all racing away from us. And the farther away a galaxy was, the faster it was receding. This became known as Hubble's law. It was the mathematical fingerprint of an expanding universe. Suddenly, Lemaitre's vision didn't seem so crazy after all. The second clue had fallen into place. In 1933, the three giants met: Einstein, Lemaitre, and Hubble. Faced with the undeniable evidence from Hubble's telescope, Einstein, now humbled, turned to Lemaitre. He reportedly whispered, "This is the most beautiful and satisfactory explanation of creation I've ever heard." The mystery was gaining momentum. The case for a beginning was building. But just as things were getting interesting, a formidable rival appeared on the scene. Enter Fred Hoyle. Brilliant, bold, and incredibly stubborn. Hoyle despised the idea of a universe with a distinct beginning. To him, it sounded far too much like religion, not science. So he launched a counterattack, the steady-state theory. In Hoyle's cosmos, the universe was eternal and infinite. As space expanded, new matter was continuously created out of nothing to fill the gaps. No beginning, no end. A perfect, unchanging cosmic landscape. And then, in a 1949 BBC radio broadcast, Hoyle decided to mock Lemaitre's theory with a joke. He dismissively called it the Big Bang. The name was meant as an insult, a way to make the idea sound crude and simplistic. But history has a funny way of twisting things. That insult became the flag under which the theory would eventually march to victory. For the next 2 decades, the world of cosmology was divided. Was the universe eternal, as Hoyle insisted, or was it born in a fiery instant, as Lemaitre had proposed? The truth was waiting, hidden in a faint, persistent whisper from the sky. The scene shifts to New Jersey, 1964. At Bell Labs, 2 engineers, Penzias and Wilson, were working with a massive horn-shaped antenna. It was designed for satellite communication, a cutting-edge piece of technology. But they had a problem, a persistent, annoying problem. No matter where they pointed the antenna, no matter what they did, they picked up a strange, faint hiss. It wasn't local interference from the city. It wasn't the equipment itself. They even climbed inside and cleaned out what they politely called a white dielectric material, pigeon droppings. But the hiss remained. A soft, steady static coming from everywhere in the sky. Day or night, in every direction it was there. They didn't know it, but they had stumbled upon the very echo of creation. At the exact same time, just a few miles away at Princeton University, a team of theorists, led by Robert Dicke, was actually looking for this very signal. They had predicted that if the Big Bang were true, the universe shouldn't be completely cold. There should be a faint, fading afterglow from that initial explosion, the leftover heat, stretched out into microwave radiation over billions of years. When a mutual colleague connected the two groups, the pieces of the puzzle clicked into place with stunning clarity. Penzias and Wilson had accidentally discovered the cosmic microwave background radiation. It was the smoking gun of the Big Bang, the definitive proof. In that moment, the steady-state theory collapsed. The mystery, it seemed, was solved. But like every great case, just when you think it's closed, new layers are revealed. In the 1980s, physicist Alan Guth uncovered another incredible twist: cosmic inflation. He proposed that in the very first split second of its existence, the universe had expanded faster than the speed of light itself. This mind-bending idea perfectly explained why the universe is so vast and uniform. Later, a series of powerful satellites, COBE, WMAP and Planck, mapped this ancient light, the cosmic microwave background, in stunning detail. They revealed tiny, almost imperceptible ripples in the afterglow, the very seeds from which all the galaxies, stars and planets would eventually form. Every new clue, every precise measurement confirmed the daring idea that Georges Lemaître had whispered decades earlier. So here is the climax of our story. The universe is not eternal. It was born. It has a history, a childhood, and perhaps even a fate. And it all began with a priest looking at Einstein's equations and asking the simple, profound question no one else dared to. What if the universe had a beginning? From Lemaitre's primeval atom, to Hubble's expanding galaxies, to Hoyle's mocking insult, to the faint hiss of a radio antenna, the Big Bang Theory became the greatest detective story ever told. And it teaches us a powerful lesson. Sometimes the deepest truths arrive dressed as impossible ideas, just waiting for brave and curious minds to follow the clues and uncover their proof. Thanks for joining us on this cosmic journey. If you enjoyed unraveling this mystery, don't forget to like, subscribe, and hit that notification bell for more stories from the frontiers of science. See you next time.